Okay, so this video is another electrostatics video looking at how we make calculations involving parallel plates. In parallel plate questions, we have two different sets of things going on. We have a set of plates called the accelerating plates, and those plates are there to take a beam of charged particles, usually electrons, and get them moving up to a high speed. So in this case, we have a positive plate over here, negative 0 is the negative plate. Electrons emitted from the negative plate are going to be emitted at very high velocity, high speed coming out of those accelerating plates. So when we deal with accelerating plates, we're looking at a change in kinetic energy for those electrons equal to the charge times the potential difference of the voltage through which they're accelerated. So delta EK, they're starting from rest, so 1/2 m Vf squared is equal to Q delta V. For this particular question, we have 1/2 times the mass of an electron, 9.11, 10 to the negative 31, Vf is equal to 5, elementary charge, sorry, no negative, times 500 volts. So our final speed works out to, so elementary charge exponent negative 19 times 500 volts, divide that by 1/2 times the mass of an electron, square root the answer, and we get a speed of these electrons of 1.3 times 10 to the 7th meters per second as they exit this system. So that's the accelerating plates taken care of. The other part of this question are the deflecting plates. And the deflecting plates are there to move the electron beam up or down, left or right. In this case, as it's drawn, it will move the beam upwards. So we have a positive plate up there, and the 0 by comparison is negative. Electric field goes from positive to negative, so we'd have a down pointing field. Field tells what happens to positive charge, so in this case we have negative charge entering, and it would deflect upwards. So while it's in the deflecting plate, we're usually looking to find either force or acceleration. So force can be found as field times charge, and in this case we solve field by looking at the potential difference for the deflecting plates divided by how far apart those plates are. And we didn't put a distance between these plates, so we should do that. Let's say that these plates are 0.05 meters, so 5 centimeters apart. So first step then is that force is equal to field, which is delta V over D, times the charge that's traveling through. So here we would have 25 volts divided by 0.05 meters times 1.6, 10 to the negative 19, that's charge of an electron, and we get a force that equals 8 times 10 to the negative 17 newtons. And then, in case the question asked you to solve for acceleration, acceleration is force divided by the mass. So we take our force and we divide it by the mass of an electron. get an acceleration of 8.8 times 10 to the 13th meters per second squared. So there is the complete how to solve parallel plate questions for both the accelerating voltage and the deflecting voltage.